We have here a distinguished panel from several real-time advertising companies who basically key technical leaders in this area. The panel members really need no introduction, but I'm going to request them to give a brief introduction of themselves, starting with Mike from AppNexus.
Does this work? Oh yeah, look at that, it works. So I'm Mike Nolet, CTO co-founder at AppNexus. What we do is we sell technology to companies that helps them run real-time businesses. So we work with real-time sellers, real-time buyers to launch ad exchanges, SSPs, DSPs, ad networks, all the various different kind of entities in the space. Major customers are Microsoft Ad Exchange, for example, on the sell side, Orange, which announced Interactive Media, which is the arm of Deutsche Telekom in Germany. And then on the buy side, we have major companies like Collective, also eBay, that use us to buy on a real-time basis. And I asked the audience to see who up here does not fit. There's one person wearing a jacket. And he works for Aerospike. No.
Yes, let me interject for a second. The person from Bulkowski was unable to attend, so I invited CTO of Aerospike, Brian Bulkowski, to join us. And he's the odd man out, so Mike's right.
Hello, my name is Mike Yudin. I am CTO of AdMarketplace. We're an advertising technology company based right here in New York, and we operate the largest search network outside Google and Yahoo Bing. We work with major, best and largest internet brands, delivering performance pay-per-click traffic to these advertisers worldwide. We were named the 8th fastest growing private company in New York. So we have a lot of traffic, just like everybody here on this panel, and we solve complex advertising problems in real time with all the data that comes our way.
I'm Dag Lioden. I'm the CTO of Tapad. Tapad is a fairly young technology company. We help advertisers reach audiences across their multiple screens. So if you're a user in this day and age, you probably have tablets, you have iPhones, you have connected TVs and laptops. And what we try to do is we help advertisers target and measure performance of campaigns across multiple devices.
I'm Pat DeAngelis. I'm the Chief Technology Officer for X+1 Solutions. We're a digital marketing hub, much more on the advertiser side. We enable cross-channel analytics and optimization across multiple touch points, typically for enterprise clients. Typically, we would do site optimization. We have a real-time bidding DSP, if you will, using AppNexus's sell side. So we actually are a partner of AppNexus. Our clients include JP Morgan Chase, Capital One, Fingerhut, FedEx, Delta, and some of the largest brands on the internet.
I'm Brian Bulkowski from Aerospike, and I'm filling in from the Bulkowski gentleman, and as co-founder with Srini, one of the inventors of our technology and database.
Thank you. In terms of how we will do the panel, what I'm going to do is to kick it off with a few questions myself to the panelists. Given the fact that the room is small and so we can be a little bit more interactive. So if you find, if any of the audience members here, if you find that the discussion is either too technical or not too technical, please feel to raise your hand. Or for that matter, if you have questions, after the first few questions are answered, I'll throw it open to more questions from the audience. Thank you. So let's get started. So real-time big data has been used in several critical aspects of the real-time advertising business. We at Aerospike have been fortunate to have a front row seat to witness the evolution of this real-time big data technology through the experiences of our customers. So this panel is an attempt by us to bring together some of the foremost experts in this area to enable other people to participate and learn about this evolution. These companies in real-time advertising use big data in very interesting ways. For example, they use it at the edge server level where they deal with millisecond level SLAs day in and day out. They also deal with taking analyzing the data and then feeding new models in there on a periodic basis, maybe every hour, every day, and so on, etc. So what I'll start with is an initial question to the panelists. The question essentially is, what are one or two instances where real-time data processing has had a tremendous impact in a positive way on your business over the last year or two? And I'll start it off addressing this to Mike from AppNexus.
Okay. So on our side, I don't know if it's a positive impact as much as it's something that without which we can't operate our business. So when we do real-time buying, which is obviously something we do, we listen to every single advertising, every single real-time ad that's available. We power a fair number of them, and that's a whole bunch, right? We see in our peak day, we saw I think 39.5 billion ads in one individual day. It's about 600,000 odd requests per second. So every second, I think right now is about peak time. So every second we are bidding on 600,000 ads. And the reality of that is a lot of that buying is being driven by behavior. And so we must have cookie data server-side. So for us, it's not a choice. We have to have a server-side data store. We have to be able to do 600,000 read requests a second. We deliver about 150, 170,000 ads a second. So every time we win an auction, we do write updates to our cookie store. And so for us, we don't have a choice, right? So for us, we've actually worked with Aerospike, and I think we were first or second? First customer. So back when it was Brian Srini in a coffee shop in San Francisco, and there were two guys, and they said, yeah, we can do this for you. And we didn't really have a choice, and because we were working with another vendor that was just truly terrible. They were name unnamed. And so we actually trusted into this, and we've had a fantastic ride over the last 3.5 years as we started at, I think, 10,000 QPS, climbing to 600,000 QPS. We probably have found every bug the first time, so good for all of you if you want to work with it. But so for us, basically, real-time key value stores has enabled all of our real-time buying business and lets us really offer this as a platform for the entire ecosystem. So what's really exciting is, I don't know if you guys know this, but on AppNexus, you can effectively use our key value store, and you can use our infrastructure and our data centers and actually put your own data in there and use that. So it's really enabled us to provide fantastic technologies and offerings to our customers.
So AdMarketplace is a search syndication network, and what that means is we look at each request for ads, of which we get about 1 billion a day or 50,000 per second, in 3 dimensions really. We look at the traffic source, where an ad is going to be displayed. We look at the user who's going to see the ad, and we look at targeting information such as a keyword that a user typed in the search box. So, and then a request gets into our system. We look at these 3 dimensions, and we have to pull data in 1 or 2 milliseconds on all of them. We have to know as much as possible about the user, as much as possible about the traffic source, and match this based on the keyword with all the ads that advertisers in our system bid on, and then make a prediction essentially as to what would be a fair price per click for each ad that matched this request, and return this to advertisers, all 50,000 requests per second. So just like Mike said, there's no question, there's no sort of supplementary value of a real-time data store. It's a necessity. Without that, we wouldn't be where we are. All the competitive intelligence of a net company like ours, and a lot of companies at this panel, is in data and how you use the data. So the more data you have, and the better access to this data you have it in real time, then you can make very intelligent decisions, and then you can have sophisticated offline processing, kind of what-if modeling, but that all happens after the fact. At the core of this is a very simple business. You get an ad request, you look at data, in 10 milliseconds or less, you return ads and then you see what happens. And that's a constant, never-ending cycle. Well, a success story, sure, very simple. One of our advertisers, Volvo Cars, started an ad campaign with us, and their goal was to actually get people into Volvo dealerships to drive Volvos. So, we started a very broad ad campaign, and we've never had Volvo as an advertiser in our system before. So, how do you know if a person who's about to see this ad has any interest in driving a Volvo? So, what you do is you look at past history of these users. We've seen, has this person searched for things like new car prices or test drive, right? And if you see a user with that type of search in the history in the last week or so, you can probably know that they're in the market for a car. And especially if that request comes from a traffic source like a car blog or something like that, that doubles your chances. So we use all this data. We successfully executed on the campaign, and I think Volvo reported that the ROI was actually higher than the search engine buy on Google. You can find this on our website. So there's many stories like this. And this would not be possible without data. Otherwise you'll just be kind of spraying and praying, as they say, right? So we don't do that. So.
Dag?
Okay, so our business is similar to what Mike here said. So we also do real-time buying. What makes our setup a little bit different from a lot of other places is that we're not just looking at individual devices, we're also looking at how they are connected to other devices. And we want to try to use that for targeting, but also for attribution reporting going after something happens. So if someone actually goes and buys something, we want to see which other devices were involved with this chain that led up to this purchase. So what Aerospike has enabled us to do is not do all these things after the fact. So a traditional, in this phase, you often do log shipping, and then you go through these logs afterwards, and you sift through and you try to find patterns, and you kind of do an offline batch processing of these things. Whereas what Aerospike has enabled us to do is we can keep this entire data set, which we call the device graph, which has data about all the devices we see and also the connections between them. We can actually query and update that data in real time. So if someone goes and buys or signs up for Netflix, they're not a customer of us, by the way, but someone buys the service, and we can go into our graph immediately, start with that device, and we can see which other devices are related to this, and we can pull that in real time. Instead of having to ship these logs to some big distributed file system like Hadoop, and then have to run a heavy job that maybe come up with a result 24 hours later. We can do all these things in real time. We can call out the partners, say, a second ago someone signed up and the cross-device impression history of this subset or a graph looks like this. So basically we have access to our entire data set in sub-second response times at all times.
So we also at X+1 have a demand-side platform which does real-time bidding. And a lot of the stories I'm hearing from my colleagues here, I can echo the same sentiment. If you can't make a decision based on as much data as possible in a few milliseconds, you're pretty much toast in that business. Where we're different, X+1 is a little bit different, is that we also do a lot of on-site optimization. And what that is basically, as an example, you go to the FedEx homepage, you're going to get a bunch of offers, right? So we're pretty down in the marketing funnel. You go to FedEx's website, homepage, their offers that they're going to provide are powered by X+1 100%. So these are pretty high value transactions. The way we do that is typically through a predictive model. So we build predictive models continuously. We have OR, processes that run and tweak these models, and basically these models execute in real time. So one side of the equation for us is to make sure that we can execute those models as quickly as possible. And the other side is to make sure we have that vector of data on that user so that we can provide the best offer. Otherwise, we can't optimize their experience and we don't get paid. So I'd say what's really helped and the success story for Aerospike is we can now onboard anywhere from 5 to 10,000 attributes for a user, put that up in our data store, and slide through those vectors with our model all day long. We can chain models together, meaning we can execute a model. If that results in fetching some more data and executing another model, we can certainly do that now as well. Data can come from offline. You know, we can get a file from someone like an Axiom with 500 attributes, we load it up, and in the next few seconds, that person goes to anywhere on, let's say, Chase's homepage, their mobile app, what have you. We have that data, we can execute that model, we can optimize, and that just wasn't possible to the same scale, before we went to Aerospike.
So it's clear that performing at really high levels is necessary for running real-time advertising businesses. The other side of the coin is to achieve 100% uptime. With the kind of weather issues we've been having lately in the East Coast, I mean, some of our customers have actually dealt with these issues. So I'm just going to go to Mike Yudin and request him to talk about. I mean, you're the first. I mean, I'll get everybody a chance, but I thought we'd start with you. Talk about how to achieve 100% uptime and how it is so important to run your business.
Okay, well, thank you, Srini. You have to remind me about the most depressing week of my life.
I'm sorry.
But it's all good. We do have 100% uptime. We lost one of our data centers in the flood. And it's not just the data center itself lost power. It's the entire network infrastructure of the tri-state major area. All the backbones. Your Verizons and Sprints of the world lost connectivity. So, and then we stayed up and we didn't lose a bit of data. How did we do this? So we do this by having a redundant, not only redundant equipment within the data center, but also have a globally load balanced infrastructure across multiple locations. So if one gets flooded, then traffic just gets shifted into the data center that survives. And the trick here is, of course, make sure that the new location has all the same data and all the same intelligence as your the system that just got destroyed. So there's several techniques in this, and one is essentially cross data center replication of data. So this was one of the reasons why we chose Aerospike. They have this ability. So our data centers exchange data between each other through the XDR, cross data center replication process, and that works quite well and is fast. And so if a user is in Chicago and they do a search for a new car in Chicago and it hits the Chicago data center, in less than a second, this information propagates to the New York data center. And so if the same user then goes to another website and then a request hits or a disaster happens, and then his next request arrives to a different location, all the data is available. And then, of course, you have to plan, and you have to have a disaster recovery plan in place, and then you have to have a plan in place for what you do after everything goes back to normal. That's what we're dealing with today. And you also have to make sure you choose a nice and sunny location for your disaster recovery office. I spent this whole
But then you get earthquakes.
where there's no earthquakes, yes. So I could have gone to the south of France in the same amount of time it took me to get to Pittsburgh, Pennsylvania. So that's my story.
Any of the other panelists wants to add their thoughts to this?
Well, I think the one thing I'll tell you we do, so first, the redundancy, DR. We were talking about this before the panel. When you have to have multiple locations, you have to have not only is in advertising actually multiple locations enough, but also understanding within each location how you're connected to the internet, right, and how you're connected to different partners. And your point around network infrastructure, many of the ISPs had major flooding inside their hubs. So, in our New York facility, we were lucky enough not to lose power, so we stayed up. But we saw that half of our network providers lost power. We lost cross connects to Google, to Amazon, because
well, that's what happened to us. We were up, but all of a sudden our traffic dropped 70% because no requests were coming through.
Yeah.
So how good is that?
Yeah, 111 8th. It's true. I don't know if you guys. 111 8th Avenue is one of the largest connected buildings in Manhattan, and it went down basically for 8 hours. And this is actually where we meet up with Microsoft, with Amazon, with Google, with all of these major companies. And so our network team actually was up for pretty much 7 days straight, playing whack-a-mole, routing traffic, trying to make it work. And then the one last thing I'll say that we do that actually helps a lot with the data is that we don't use the Aerospike replication. We wrote our own replication layer, and what we do is we replicate incremental changes to all of our user data. So if one thing we track a lot is how many ads you've seen, right, and of course behavior. And the problem is let's say I have your resume, right, and I have that in your key value store, and let's say I change the resume both in LA and in New York, right? How do you make sure that both copies of the resume get the exact same change? One way is to send the whole resume across, but then you end up actually, if you have conflicting changes, you can end up losing data in the middle. Mm-hmm. So what we always say is we're adding a line to the resume at this location, and we might do that multiple times on multiple records on the same user. And then even if we lose connectivity or something weird happens, whenever that connectivity comes back, we stream those messages back and forth to each other, and so that in the end, those two copies end up being the same again. So I think that's one technique we've used very successfully to make sure that our user data in the end always ends up being 100% the same across all of our locations.
I'd like to add a follow-up to Brian. For example, AppNexus has been our first customer, so our cross-data center support only showed up last year. So I'm asking Brian, is Aerospike going to solve these problems that?
Yeah, but I wanted to share another customer story, which was our first deployment with cross data center was with a company many of you probably know,
Exalate.
And Exalate has three different basically data pools: a U.S. data pool, a global data pool, all of them replicating among 4 data centers. So what happened to them was they lost one of their New York data centers as well. Everything backed up on the servers, the data center feeding New York, which is fine. It ended up, when the data center came back, re-replicating. What they did say that was interesting was they actually had to call us because when their New York office went down, they had IP-based security into their data center. So they couldn't actually get into they'd abandoned their office, and at home they couldn't actually get into the data centers to do a graceful shutdown of the servers. So they had to call our support guys and say, hey, Kevin, can you please take down those servers gracefully, because we just got notice that there's only 30 minutes of fuel left. We were happy to oblige and help them take down their servers gracefully. So that's the kind of thing we do, and we only a few of our customers actually lost full data centers. But as you say, connectivity was really the issue. In terms of being able to support at our layer both what we call delta shipping, which is just the updates, which is basically the technique Mike was talking about. We'll be having that in a release probably in the next 6 months or so. It's an important technique both for bandwidth resolution as well as getting the correct data and not losing updates.
Okay. Dag, did you want to say something?
Yes, I mean, cross data center replication redundancy is important, but of course you also need to have intra-data center redundancy, and this is where this product also does a really good job in that if you lose a node, you have routing in the clients and in the server, so they will route traffic to wherever the data is. If you add nodes, you don't have to plan for it. You can just add nodes, and they will automatically start sifting data from the other servers. And I mean, data centers do fail. Fortunately, they don't fail that frequently. Servers, they fail pretty frequently, or they don't even fail. Someone just takes them down by mistake. I think that happens quite a bit as well. And we've seen that happen a few times, and fortunately, it hasn't really affected us.
There was a hand raised in the audience. Is there a question from the audience?
I got the answer.
Oh, okay. Okay, that's great. So please do.
Question.
Please.
So I have a question. Can some of you comment on what lessons have you learned as you scale the system? Something that's not obvious. For example, I saw a post by Mike, I believe, where you said you hate load balancers. And so I'm just curious, what advice can you give about what did you learn as you scale your systems? Or maybe you can also, as we talk about this, just mention what technology stack do you use?
That's a broad question. Well, I'll give you two answers to that. So, specifically to lessons learned, I think for us we found anything that's not simple will fail. It's probably, and now we're rare in terms of throughput and volume because we're just running on so many servers, running so many ads every single second, and that the simpler the architecture, the fewer points of failure, just hands down is the best, which is actually why we threw out all of our load balancers, because at some point we found that load balancers start dying at 600,000 QPS. So, and we found that we had more outages due to load balancer issues than we had to application or software issues. And so we ended up effectively embedding load balancing into our own direct applications, and magically things got a lot better. And so I think simplicity is just hands down where you actually want to be. And then the second one is full end-to-end automation of everything you do, right? I mean, your example about manual error, right? People fail, right? People naturally fail. They'll fail 80% of the time on the average day. This is not a problem. This is not a bad person. You're a good engineer will make mistakes all the time. And at 2 in the morning, you make mistakes most of the time. Right. So
I agree.
Anything that's not automated will have production issues. It's really that simple. If you can't point and click deploy what you have, if you can't point and click rollback, and if you can't point and click debug, you will simply have production issues because at 2 in the morning, someone fat fingers, types the wrong thing, and oops, shit, I did something wrong, right? And so one, keep it incredibly simple, and then automate the snot out of it is what our head of tech ops actually says. And you look at where we have production issues, we're not perfect. The only places we really have serious issues is where we do not have full automation in place, where we can't just spool up a new server or fail over a data center or anything like this. In our stack, it's almost all homegrown. We use Aerospike for key value stores. We use Vertica for columnar databases for reporting. And then the rest is Hadoop. I don't know if you call that license because you have to do so much engineering around Hadoop to make it work. And then everything else is homegrown software for us.
Mm-hmm. So I could probably add to this. Mike is saying, keep your system simple, and that's totally the key to this. So the way you keep it simple is you have to be very smart into dividing your intelligence into online and offline. And you do all the heavy lifting, all the predictive modeling, all the crazy algorithms offline. And then what you program into your real system is just really quick lookups. And another advice is to keep your system asynchronous. Because as soon as you have components, depending on other components, and everything waits, for the other thing to respond, and when everything is fine, everything works just fine, but then one little thing is going to fail, and there's going to be a cascading effect, and everything is going to come to crawl, and then you just have an avalanche of degradation in your system. So you have to have a graceful degradation policy, and you have to have asynchronicity as much as possible. And we just had a discussion right before we officially started about blocking threads and doing these kinds of things. And I mean that's the key to this. As far as technology stack, I mean we were also just discussing this. Pretty much anything works. In this day, hardware is powerful. User-proven platform, whatever this is. C, Java, .NET, they all work. Probably not a good idea to program your real-time ad server in Ruby on Rails, but other than that, hasn't been a problem. What's the question? What's beyond Hadoop? I'm not going to tell you because we don't use Hadoop. We don't use Hadoop that much. We found it's too slow for us. I mean, the processing cycle of data in Hadoop is just. Well, the main principle of Hadoop, it's a distributed kind of grid computing system. I mean, that's not going to go anywhere, and you have to do that. So, and people are trying all kinds of things. We ended up writing our own proprietary system. Okay, whether this is going to become the internet standard or not, I don't know. But probably like some of my colleagues, we found that very, very few commercial or even open source solutions actually support the scale that we need. So we ended up programming a lot of this ourselves. It's kind of tragic, but that's what it is.
Please.
Yeah. So I would say, in terms of what lessons learned, metrics. Keep metrics of everything, because scale kind of creeps up on you. You start seeing your latencies jitter, and you want to correlate it with, you would try to figure out what's going on. If you're building an ad tech system, you have a lot of moving parts. You have a lot of endpoints that get hit. These have different impacts on your system. And if you don't have metrics, you're pretty much blind. And scale, I mean, web traffic shifts, it grows month over month. We're hooked into AppNexus, and they get more traffic all the time, and they're like, one day, all of a sudden realize, oh, crap, we're over, things are starting to jitter a little bit, and we see, yes, we're now more than 100K QPS, for instance, and we see that it's this kind of traffic that causes this kind of ripple. Any sort of debugging, if you have any sort of performance regressions, always looking at the metrics is the number one thing that we use for debugging. You can't live debug and step through code in production, and sometimes the only way you can debug some things are actually hitting them with real traffic, unless you have unlimited resources. But metrics is what I would say. And beyond Hadoop, a more efficient file storage underlying it first, I think. That will do a lot. Having flat files for everything is...
From the standpoint that Hadoop is not the answer, everybody knows that. So, like, what's the future?
Why do you say Hadoop's not the answer?
Well,
I don't think that... So Hadoop is a lot of things.
I think we're going a little bit off the topic. This is about real-time big data. Hadoop is not real-time in any way, shape, or form, as far as I understand.
I understand that there's a lot of people try to write plugins and,
Yeah, it is a way to, for example, how Memcache speeds up MySQL is the same philosophy there. But then there are things like Aerospike, there are a whole bunch of other NoSQL databases. They try to actually do a database at the speed of a cache. So beyond Hadoop, if you ask me, I'm biased. I would say Aerospike 3.0. But doesn't mean.
Yeah.
I'm sorry I started answering that question. We can talk about it after the
I'd love to make 2 points. So one, you only have a certain amount of tools in your toolbox, right? Hadoop is one of those tools, right? And if you try to screw a screw with a hammer, it doesn't work very well, right? Just like if you try to use a screwdriver to hammer in a nail, it doesn't work very well. So Hadoop is the right tool for some things. Aerospike is a fantastic tool for some things, right? Vertica is a fantastic tool for other things. So I think the problem people make with all of these, including key value stores, is that they try to smush too much functionality in it and try to make it too general purpose and try to make, the super fancy multi-tool that does, everything, and it turns out being pretty mediocre at everything. And when I get pitches from vendors, a lot of times if they sell me too much, right, then there's a lot of these people working on distributed real-time MySQL systems. And one of these guys came in and actually pitched AppNexus and said, we can be your key value store. And I actually rejected it outright, simply because I don't want a key value store that does SQL, right, and joins. It means it's a multi-tool, right, which you just know is going to have some kind of complicated performance issue, because it's just too complex for what I want. And I hope that Brian and Srini don't try to turn Aerospike into multi-tool, and that they understand what they're really, really good at, which is having kind of key value, kind of NoSQL-based data and incredibly low latency, incredibly fast, right? And so I think that's the best answer to your question, is that Hadoop is a tool that's good at some things. Aerospike, there's new tools coming out that are really, really, really exciting. And Aerospike is one of them. I'm also very excited about stream-based processing, which I think we're going to start seeing more of, which is, could be, I don't know if you guys are talking about some of this or new products or things like that. But, that's, I think, what's going to get really, really, really exciting.
I didn't mean to concentrate on Hadoop.
No.
Yeah.
What are the stacks?
Okay.
Well, I would like to add to this a little bit. There's more and more companies you see at trade shows like this that are always on the cutting edge, and they have the most sophisticated algorithm, the most amazing model ever. And Hadoop is just not good enough for them, and anything is not good enough for them because they process so much data. dev to do the next coolest thing. And the truth of the matter is that there's very little actual working models and intelligence in this advertising world. Few things really work. So if you're trying to solve a really complex problem, beyond capabilities of the standard stacks and proven technologies, I'm going to bet you $100 you're probably not trying to solve the right problem.
Well, can I, and I'm sorry, and then I'm going to totally let you take over. But I think what you just said is exactly true. What happens is doing something at low scale. Like what you hear is all the CTOs, I don't know if you noticed, every question we're saying, scale, 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 scale kills, is because it's very, very easy to build an online advertising product at low scale. Right? It's very easy to build a super snazzy, dynamic creative that's interactive, it bounces up and down, it talks to you, it uses your webcam, you can get real-time reporting on the back end. If you're only serving a couple thousand ads a day, no problem, right? I got an engineer who can turn that around for you in a month, right? The problem is when you start doing it 1 million times a day, and 1 billion times a day, and 10 billion times a day, and 40 billion times a day, that's when all those features and functionalities that you have in that really cool product break. And one of the problems with innovation in online advertising is that people don't think about scale. People raise VC money, build a prototype that does lots of really cool stuff, right? They say they do it at scale, but it really doesn't do it at scale. And then they hit scale, and then the shit breaks, and then you have to rebuild everything. And there just aren't enough commercial tools out there to make these problems and go away. And so you end up suddenly needing 40 engineers to try to make all of this actually.
For the right job, as Mike got to, and be willing to iterate and explore before you get into production. I mean, we have a lot of complexity, I would say, in our system, but we've approached it as splitting that problem up into as many discrete parts as possible. Again, echoing the sentiment, it's got to be testable, right? It's got to be modular. If you want to stream it, you want to communicate. We use something, 0MQ, there's a lot of queuing out there. There's ways to communicate among these different components, and that way you can test them. And we are very, very diligent about metrics, as Dag mentioned. If you write code in our system or for our system, that thing better log and let the world know what the hell is going on with that component at pretty much at every step of the way if it's interrogated. Because if we can't, again, echoing the same sentiment, if we can't look and see exactly what's happening inside any of these components, we're screwed. And you're flying blind, right? And then we can start testing them. We can run through any regressions we need to, and we can see where the bottleneck is going to be. You'll never catch all of them. Sometimes you don't catch them. Hey, you know what? We never thought someone was going to do 25 placements on one page with 50 models. Sorry. Okay? Didn't. Bad on us. But you can catch a lot of that stuff, and at least you can pinpoint it. Otherwise, again, I don't see how anyone would even want to go to work in the morning without knowing how everything's operating.
Okay, Brian?
So I'm going to add, you did, when you asked your question, you said something that's non-standard about scaling. One thing I'm happy we did at Aerospike early on is that most clustered databases, for example, Oracle RAC, many other the support-based systems, charge you per node. And what happens every single time then is the ops guys who have a feeling for the number of nodes they want in order to have the resiliency they want, they get crowded out by the business guys, and there ends up being some long involved conversation about, well, do I really need a 4-node license? Why do I have to buy a 6-node license? All that stuff. So one thing we did to make all these guys more successful and the whole product more robust was our business model. Plenty of technology and all of our logging and stuff like that, but I wanted to say, hey, look, let's have your ops guys, have them really figure out what they want in terms of the reliability, the number of copies of the data. We'll decouple that from the license terms. And, so as you start iterating, seeing your load go up, you need to add more servers. Great. You're not calling us. And we want you to do that and feel comfortable with the amount of hardware you have without having to start thinking about license terms, because then people's heads explode because where's my budget? I didn't ask for enough budget. I have to justify more, stuff like that. So think about the impact of your business model with your scalability.
Is there any other questions from the audience? Okay.
When you were talking about building scale, the problem that a developer can say they're building scale, then all of a sudden finds out that once you hit scale, things break. I've actually witnessed that, to be honest with you. I was working with a company that actually experienced that. I felt awful for the company. The programmer, I think, was trying to do that. I don't think it was something like, I don't know, they didn't make mistakes, maybe they weren't that much, transparent. At the end of the day, I mentioned that mistake, but what I'm trying to get at is, how are you able to observe the developer and make sure that they're able to do what you need them to do if you perhaps don't have that development skill yourself? Often what I like to do is if I hire somebody to do a job, I try to do the job myself, just to get an idea of what it takes, like what they're going to do. When we talk about development, it's a whole new world. It's scary a little bit. I mean, that's my problem right now. It's not really scary. It's just tools, and that's what it is. But what do you guys recommend? I guess with your experiences where you went through this challenge so much, but what do you recommend to somebody who doesn't have that?
That's a hard question. Of course, it's hard to design scalable systems from scratch. And I first of all, I think it's a mistake to always keep, like, how do I scale this to, I know if you're at AppNexus, you need to scale it to a certain level. And even if you're us, we're not in that scale, but we're still in like very high scale. But if everything you build is always constrained by scale up front, then you will lose momentum in your innovation. So if you it's okay to build prototypes that don't scale so well, and if they actually turn out to have value to your business, then you can go back to the drawing board and see how you can make it more scalable. There are a lot of things that are easy to scale, and then there are some things that are really hard to scale. Doing everything right from the beginning, unless you've built an exactly identical system before, I think is impossible. But engineers that have built similar systems or are interested in staying up to date and knows about the different tools, this is kind of one of the things we're at here is that, so NoSQL is the new acronym for everything that is not a relational database, pretty much. And it is a lot of things. If we talk about just storage, and finding the right tools and thinking about that up front can be useful, but it can be retrofitted too, to some degree. I mean, Twitter, when they moved off their Ruby stack onto the JVM, that's gotten a little bit of attention now over the past couple of days because of the election, and they gave credit to their switch. That was the reason why they were able to cope with the spike in traffic now a couple of days ago. But anyway, my point is that if they started out thinking about services and decoupling and building a system the way that they do now they would probably never have gotten to the market at all. So I agree with what Mike said about it's easy to build something that's really fancy and works with 1,000 users or 1 million impressions a day maybe, but if you go into trying to build a new product only think about what's going to happen when I have a gazillion users, then you're not going to make a lot of innovation, basically.
So in a way, I guess it's kind of like, and I like your answer, but just so I can summarize it. In a way, it's kind of like if you're doing well and you're building scale, most likely stuff's going to break anyway. Scale.
Be prepared to make a lot of mistakes. Don't be afraid of that. That's for sure.
Cool.
Yeah.
Anybody here not making any mistakes?
Yeah, sure. But I think also the question was, how do you teach developers to develop at scale?
How do you become aware of what the developers are doing, or how do you get yourself to where you need to be communicating properly if you're not a developer yourself? And one thing that I like is I actually like to use Visual, but the problem is that I don't think I use Visual properly. So
I think the answer is you have to know a really few basic principles. And if you follow these principles, you can reach decent scale. And these principles are, you don't make calls to SQL databases in real time. You don't make synchronized components. You have to have metrics, and you have to have instrumentation so you can see what's going on, right? You don't there's certain anti-patterns that you just don't do, okay? And you will encounter each of them, if you're doing this for the first time ever, you'll probably have a lot of failures, but you'll learn.
And part of it,
business person.
Sorry to interrupt here, but this discussion is complex as you're learning, and I mean, every one of us here has learned from our experience as to how to deal with this. It is possible, I can guarantee you, but it is extremely hard. So I think we should probably take some of this offline, unless, okay. The other one is okay, is there any other question from the audience? Because I want to give audience priority before I have a whole list here. Okay. So the next question, I wanted to ask a specific question to the panel, which is, can you kind of talk about an actual problem that you had to solve, over the last year in this real-time big data space, and what product or technology you use? It could be, something like a key value store. It could be your own homegrown thing, but there must, but it must be in production. So, so pick your. So we'll start with Pat. Maybe.
Does it have to be Aerospike?
No, of course not. I mean,
we actually have done a lot. Sorry, we had to solve a problem of cross data center replication, and even when we have Aerospike now, it's not quite what we need. But even before we had it, we had the same problem, or a very similar problem that Mike N described before, and that is, we could step on a record. We need to basically journal our changes. If something about a user changes, that needs to be journaled. That needs to be shipped across to another data center and applied. We can't just do a wholesale replace of our objects across all of our data centers. So that is one case where we used a homegrown solution using, again, 0MQ, which is a very simple lockless queuing system. And we were able to journal our transactions, ship them across to all of our data centers, update them, and keep them, I would say, eventually consistent without any major headaches. And again, there are other queuing products out there that are commercial or open source. 0MQ I would call more of a toolkit or a framework. But again, if you need to understand what your replication needs and requirements are before you make any of those decisions. If it's okay to blow away an object on the other side because it's out of date, then you can just fire and forget, as they say. But that's probably the latest thing we've solved.
Well, a very significant problem that we try to solve, we haven't solved it yet, is how do you combine all this real-time data with analytical data? So we have this real-time data stored in Aerospike. It's a fantastic, for really fast key value lookups, and it works. But then imagine that you would like to have access to all the same data and look at this not one user at a time, not one object at a time, but find patterns in it, cross-dissect it, make it available to all your dashboards and UI tools and algorithms, and look at this data set as a whole, not as each individual key value, and keep all of this data in sync. It's a very difficult problem. So far, we found some hacked up solutions to this. Basically, back the whole thing up, import this into a more friendly, queryable system, be it Hadoop or be it Vertica or something like this, and join it with the rest of your data, do aggregations on it, because you cannot do this in this type of real-time data engine. It doesn't work.
And we're getting close to the end of our time, so let's keep the answers brief. Dag?
I would say that making the data feeds into actual feeds that are consumable not just by batch inserts into databases or into file systems, but actually making them something that you can tap into and have easily extend your system with new types of analytical processes. So if you want to try, Mike mentioned stream processing, which is something that we've started tapping into over the last few months actually. How do you plug something that into a system if it's already based on shipping log files, or if it's something that is happening internally in machines somewhere? You want to kind of democratize your data by making it accessible to new consumers of that data. There are a few interesting big data queuing systems coming up now. We opted for one of those.
Yeah, likewise.
We run with Kafka now. That was a big shift for us. It also made our system more resilient. The asynchronous is easier to handle. We can now easily handle failures in our data stores and so on if that happens. But yeah, that's a problem that we've been solving recently.
So it's funny. I love your answer. So we did two things recently that changing basically how we stream data. So we built our own data streaming a couple years ago. So we can we generate about, so every one impression generates on average 10 to 15 log records. So we've got 6 million log records a second or so that we're dealing with. So we have our own streaming infrastructure for that. And we added the ability to start splicing data. So we can now take our stream of data, we can splice it, and we now actually have started streaming data to multiple places. So it goes to Hadoop for our standard hammer to do aggregation. We've now built a very highly optimized, it's not quite streaming, but every 2 minutes we load into an HBase infrastructure where we keep an offline copy of our key value data. So we basically do every data record we have in Aerospike, we're also re-replicating inside HBase, which we can now do to do offline conversion attribution, all sorts of really, really, really exciting offline stuff. So we're going to get to the point where it can do true multi-touch cross-channel attribution for any one of our partners. And it's really been actually doing stream-based processing or stream-based log, and especially being able to splice that data into different places. The third thing, we have a prototype a guy actually just put together with VoltDB, where they now take, for several of our clients, they stream the data into VoltDB in real time, and they have a prototype of real-time reporting, which I actually don't know how useful it is, because in general you need several hours of data for interesting data, but it's really cool, and it actually works. So, what's interesting is that there's just no open source or commercial tools yet that do any of this. So this is a lot of the challenges we face is you have to build all this stuff from scratch. And what's funny, 5 years from now, I'm sure there will be an open source tool. It's a fantastic commercial opportunity for somebody. It'll make it just easier for the next guy.
And I'll just add to Mike, we use our journals replication journals to feed a database, as you were talking about, Mike. That's how we do it. So when someone's state changes, if you will, they saw an impression, they move segments. Since we journal that to ship it across data center, we can ship that to a Vertica database or something like that and get an up-to-date view of the customer.
Okay, we have a couple of minutes left, so last question from the audience.
Mike, do you have any plans to open source any of the work that your team has been doing on stream processing? Why or why not?
No, because it's, for us, very core IP, right? In the sense that when it becomes commercially available, sure, we might, it might be good for us, but at the moment, it really gives us a huge advantage that it's a generic infrastructure. Any developer at AppNexus who wants to get data from any of our data centers, from any server into one location, just types a config, streams in data, and it magically appears in whatever data source they want. So it really gives our developers just a fantastic set of tools to run. And I'm not sure we want to just give that to everyone else just yet. We are working on another couple open source projects, specifically around DevOps systems, continuous deployment, where we feel the open source community we've benefited a ton from, and we're pushing back and sharing some of the things we've built on top of Puppet and things like that.
Okay. Let me ask a final question. It's not as technical. Who's the one person who has helped, kind of unexpectedly helped in your career or in your business over the last couple of years? It could be your mother, it could be anybody, but it's somebody who should have affected the actual business and career. Dag?
Well, thank you.
I have an answer for me if you want to ask me the question.
Can you hear your answer first?
Well, it is an advisor for our company. He's an IBM fellow. I worked for him 25 years ago. And then he joined as an advisor. And then he's been so key. His name is Don Hederle. He's the father of DB2, actually. And he's a completely relational database person. We're doing NoSQL, new database. But he's kind of taken us through, taught Brian and I what exactly we were doing when we didn't understand what it was. And has been a great help in explaining this to other people, including investors and customers, like Fortune 5 customers and so on. So, that was completely unexpected, but happened. So that's the kind of...
I don't have one person, but I have one group, which has been the New York CTO Club. I don't know if anyone else here is a member of this club, but it's just an absolutely fantastic group of people. We've managed to be lucky enough to convince 2 of the members to join full-time so far. So we're we're trying to. It's also a recruiting pool, it turns out. But it's having advisors who have, to your point around scaling. The reality is anyone who hasn't done these things before will make the mistakes, no matter how smart they are. I mean, Michael's rules are fantastic, and if you follow them, you'll make fewer mistakes. But fundamentally, you need people who've done this before. And many of the challenges are not technical, they're organizational. They're around how do you align people, how do you set them up for success, and I've been very lucky to have access to just such a fantastic group of people who has really helped me be successful as a CTO and has helped AppNexus scale, and both by just advising and helping and also hiring, which is good.
Well, so it was a very unexpected question, and my answer to that question would be somebody who's completely non-technical. And that's the CEO of our company, Mr. James Hill. So he really taught me how to simplify and crystallize things. He's very good at asking questions. What is it? Why are we doing this? How are you doing this? And what I learned over the years, if you can't answer these questions quickly to a non-technical person, you probably don't know yourself what you're doing and why you're doing it. And you're probably not going to be very successful in what is it that you do, in all the underlying technical complexity, which is, if you hide behind the technical complexity and you can't have simple answers to basic questions, you're not doing something right. So I'm very thankful to him for being that person.
Well, I don't have any specific people. What I do find is somewhat related to that, and at talking to regular people that are not in advertising is an extremely interesting way of trying to cut to the core of what you're doing as a company. Because the stuff that we deal with in the ad tech space, all the buzzwords we have, all the fancy words, to your point about the models, about predictions and big data and all that stuff, if you can't cut that down to someone and explain it to someone you meet at a random party, then it's a very useful exercise, I would say.
I don't have a person either. I would. It's going to sound corny, but I would say my team, who's helped and who's built all this stuff and who operate everything every day, and these are the guys, as Mike has seen, who drove to Pittsburgh. Sometimes you have to put in a heck of a lot of time, and I don't care how bright of an idea you have, how smart you are, how great you are. If you don't have a good team who's willing to do basically whatever it takes, you're not going to be successful, in my opinion.
Okay, well, Brian, did you want to?
I was very surprised that our investors, VC group, usually as an entrepreneur, you think, you know what, you say nice things to your VCs, but then, you take the money and you say thank you very much, and you use the money. That's their primary contribution. And anything they give you on top of that is gravy. But our first-round investor, lead Joe Diego at Alsop Louis, has actually been an immense help to the company. I think one of the benefits is he's very new to the VC game, so he's not as blasé. And he has a great operational background and a great sales background. So in terms of helping us through the thicket of hiring salespeople, especially, who can be, very persuasive in person, you have to figure out who's actually good. Back to your management question. So I want to put a shout out to him. He's been a great help through this.
Okay. Thank you. I think that brings us to the conclusion of this panel. I'd like to thank each and every one of the panel members for making time out of their busy schedules. They're all running 24/7 systems. Their teams are running them, and if it's down for 5 minutes, they don't make money. So they're here because they've actually figured out how to solve this problem. So thank you very much, and also for a great experience here. Thanks to the audience for the questions.
And Srini.
Thank you, Srini.
Thank you very much.